Hello guys. So this time I forgot to mention the other equation of the gases, okay? The Vander Waals equation. So this is not very familiar in chemistry because our focus are centered on the ideal gas law. So in this real gas using the Vander Waals equation is equals to the PV over nRT is equal to 1, something like that. So the value of this will be equal to 1. So this is known as the real gas. Okay, pressure times volume over the nRT, PV nRT, and the nRT will be in the denominator. N is the number of moles, R is the ideal gas constant or the universal gas constant, capital T is in Kelvin, and then the numerator will be pressure and volume is equals to 1. Okay, and then it obeys the molecular attraction. It has been considered the molecular sizes of the gases, so it's more complicated compared to the ideal gases, something like that. The behavior is more complicated. So, and also, of course, the formula is also complicated for the Van der Waals equation. So I think it's gonna be pressure plus, I'm not really sure, but I'll try. N squared over times A over V squared, and then close and open parentheses, multiplied by volume minus N times B, then close and open parentheses, is equals to nRT. So there will be an introduction of the pressure fraction and the volume fraction. The first part, in which P plus N squared A over V squared will be the pressure fraction. And the other part is the volume fraction, which is volume minus N times B. Close and open parentheses is equals to nRT. So N, small n, is the amount of substance known as the number of moles. And A is the constant, the small letter A in the first pressure fraction is a constant. And B is also a constant in the volume fraction, like that. Okay, that's the basic equation of Van der Waals equation. Okay, again, pressure plus N squared times A over V squared. Okay, V squared is volume, yes. Okay, and then times V minus NB equals to, I will write that one so that it will be clearly understood, right? Okay, but I'm not really sure if it is correct. Okay, correct me if I'm wrong. Okay, because maybe it is not correct because it was a long time ago. Long time, in a long time ago. So yan. Okay, this one, Van der Waals equation. Okay, P plus N squared A over V squared, like this, and then V minus NB, okay, is equals to nRT. Okay, Van der Waals equation. This is one, Van der Waals equation. Okay, this is the basic formula of Van der Waals equation. This is not common and this is not really used all the time because we are focused and concentrated in the ideal gas law, which is the PV is equals to nRT. Okay, and the other gases also, the combined gas laws, okay, the Charles law, the Boyle's law, the Gay-Lussac's law, the Avogadro's law, and the Dalton law of partial pressures. Okay, like that for the ideal gas laws. This is not really common, and I don't think so that there are problems like this. I think there are, but it was not discussed because this is not really important as ideal gas. That's why I interpreted. Okay, this is only an idea of the Vander Waals equation for real gases or non-ideal gases. It is the exactly opposite of the ideal gas, in which PV, pressure times volume, is equals to nRT. Pressure times volume over nRT is equals to 1. Okay, thank you so much.